So my name is Vlad Voina. I work for ROLI. I am a software engineer, and I tend to spend most of my time writing GUIs, as Tom said. It's quite interesting. I'm also a Goldsmith student. So if my voice is a bit shaky, it's because I'm nostalgic, not because I'm nervous. So yes, I'm going to talk about building modern GUIs fast with Projucer. It's quite a long title, but it will hopefully make sense by the end of this talk. And the first thing I want to address is, what do I really mean by modern? It's quite a subjective word these days. What I really mean is a few things. So I mean vector-based graphics. That is essentially not bitmaps, which I'm sure a lot of you are used to, and it's still a very common practice in the plugin sort of like interface design. So what we tend to do here is we tend to have paths and primitive objects that draw rectangles and circles, and we use that to define our interface, which obviously scales better, and it doesn't depend on DPI and all these kind of constraints that you have with bitmaps, and I'm sure you've suffered a lot from using bitmaps. Another trait is they are responsive and dynamic. So that means if you resize your plugin window, your interface should adapt to a new size. And by adapt, I mean look nice and not just clip at the edges. And it should also maximize screen real estate. So again, it's not just about shrinking everything or zooming everything down. It's about maybe rearranging elements so that it uses space a bit wiser. And there's another thing, which is animations and transitions. I know that is not still great in use, so I'm not going to cover that for now, but maybe in the future. So here's two examples of a nice flat UI. One's NI form, and the other one's a propeller heads figure. But I'm not going to get into any details here. I don't want this to turn into a design talk. It's not about that. But just to give you a bit of an example. And this thing that I'm sure you've seen before, we've coded it with these traits in mind. So I'm going to quickly demonstrate, not that guy, this, what I really mean. So this is the noise interface for iPad. It's got these elements at the top. It's quite a lot of them. So if I start resizing it down, at some point they disappear. This is all done dynamically in the resize method. There's very little ifs and changes of logic. It's not at all switching views. It's dealing with the lack of size here. So it's removed a few elements, but they're not gone completely. There's this little carousel now, I'm not sure if you've seen, that you can now slide. And if I increase it again, as soon as there's enough space, they come back in. That's one thing. The other cool thing is this. So this is a very common example. Now, a lot of these things, has any of you here done web development? Yeah, so a lot of these things will probably seem like a joke to you, but in C++ world, it's not a joke. So hopefully it'll be entertaining. So we've got 6 elements here. As soon as I reduce the size, boom, it goes into one column. If I make it big enough, it's going to go into 2 rows. So that's pretty cool. Got banger, yeah. This is another interesting one. So plenty of space there for a vertical column to show items. As soon as there's not enough space, switches layout, and now shrinks. I mean, it's not very usable at this point, but it doesn't look that bad. And I haven't seen a phone that looks like that yet, so I think we're fine. So before I start showing any details, I just wanted to address this question, because some of you might be wondering, why even bother, man? Like, there's other languages out there that are just much better at this kind of stuff. And I agree. I definitely would seriously consider not using C++ if I were just starting a new project. But as Stefan said previously, C++ is the most widely used language, so I'm sure a lot of you are using C++. So I'm not going to sit here to convince you to use C++, but if you do use it, I've got some pretty good tips. So, and then if you do happen to use it, there's some pros as well, right? So it's just simpler to think in one simple language, not simple language, but one language at least. You don't have to switch languages and change the way your mind reads code and stuff, and then you can have one uniform code base, set one coding style. Everyone can quickly follow up on that. This is a tricky one. So it could be easier to hire and train. I think if you're a small team and you've got just a handful of developers that are quite proficient in C++, it'd be quite good to just quickly transition, build some GUIs. If you're a big company, then maybe this is not a great idea, because you might want to hire people that are just focused on one simple declarative language and can just write that very, very quickly. So yeah, there's a few other benefits. No overhead dealing with managed and unmanaged code, and actually C++ recently is becoming a bit more friendlier. So you get like slightly better constructs that make the language a bit nicer. So yeah, I think at this point I'm going to start to get some code down. So how many of you here have worked with a designer at your professional business? Like a proper designer, like someone who just does design. It's fun, isn't it? So this is a very common example, right? Can you move this text label just a bit below? All right, can you move that above? And then you do this a few times. And I think this is the main cause of hair loss. So yeah, and this is not their fault, right? This is not their fault. They have to do this. Designing something that works and is beautiful is an iterative process. They have to try quickly, prototype quickly. So your job is to react quickly. It's not to blame him for changing his mind or stuff like that. So what we end up doing is we end up being pixel shifters. So this is a common flow, yeah? You find some relevant code. You get distracted by some JSON logic, obviously, and it takes a while to familiarize yourself with that code, and then in that process you refactor it a bit because you just want to make yourself feel better a bit. And then you just realize that wasn't actually the right label that you wanted to move. And then you have to go back and do the same thing again, and eventually you find it. And then you make the changes, and then you build and wait for it to build, and then you run it. You navigate to the part of the interface that you've changed, and this could be like deep in menus, right? And you make a change, it's not quite right. It's never right in the first time. You need to do it a few times and go through this process a few times, and it's just, yeah, it's frustrating, yeah. So I wanted to suggest a slightly better workflow. And I'm going to go straight to Projucer to do that. Let's make this even smaller. So what I'm going to do, I'm going to have, this is just a little, actually this is not just a little, this is actually noise for blocks. So you're seeing here a real-life example of what you've played with, actually following this pattern. So let's say I want to go to, actually I've got it right here, but just for the sake of this, I'm going to find it here. Oh, it shows up on the screen. There we go, wait a sec. Yeah. So this is the little project card that you've seen in that project view, and I can resize it here. I can see how that looks. I could also go to view the code, and let's say I wanted to make that gradient slightly wider. So that seems to be here. Quickly see how that looks. Let's say I wanted to turn the content around so that it's actually reversed. So I've got this left here. Yeah, this is. So at this point, Projucer starts building again. Now, This is not very, very fast at this point. It could be much faster, and that is because we include everything in one big header file, which is what I'm sure Stefan would cut my hands for, but we can improve this. So eventually it builds. And here we are, it's the other thing. So that's slightly better, right? So you find the view in the Projucer live components list, you change the code, you see it change. You do this a few times, obviously, but it's much faster than having to go through a project and then, you know, you get to live longer because it's just not wasted time. So there's a few things that you need to do before you can do all of this. It's not something that you can just quickly just do. It's with large-scale projects, you have to, there are a few rigorous guidelines you have to follow. So I'm going to go through a few. So I've got this little code example here. It seems to read. I have to say it's been quite hard to find like a code that fits on the screen and kind of demonstrates all the bad things that I want to talk about and then the good things as well, obviously. So this is this maybe not a very practical example, but I hope it makes sense as I go through the cases. So the biggest problem when you want to modify GUIs and do it fast it doesn't have to do with anything but just bad code. So bad code is bad. There's no other way to say it. And this is a very huge topic. Like I could spend days just talking about this. And there are actually better people to talk about this. I don't know if you've seen Jules' talk from last year. It's a huge subject. But I'm just going to go through a few very common things that I've seen. Some of them are minor, some of them are less minor. So let's look at this bit. Slider 1, slider 2, slider 3, top slider. Oh, great names. They're two, it's just difficult to know which slider is which, so you're going to have to run this, and I don't know how you find out. And what's even more difficult is that what used to be, so this is called the top slider, but actually in the meantime it's changed, so now it's at the bottom. And this happens, you know, someone will come and they will need to move and they'll forget to rename that variable, so you're going to waste a lot of time. I think these are slightly better names. So coming with more contextual names that you know are not going to be affected by layout changes is going to make your life much easier. Here's another interesting fact. So this is using scope pointers. This is something that I see a lot. These don't really need to be scope pointers. We don't need to create these, you know, in this kind of fashion. We have all the dependencies, all the resources ready when this slider is created, so why not just make it on the stack simple, like that? And obviously all that code at the top goes away, so it's less code, better. Another thing that is maybe not so obvious is logic in callbacks. So this is very common. You have a slider drag started, and then you want to run some logic as a result of that. So you start writing the logic inside the actual method. And this is a simple case, but this usually leads into much bigger methods that take various variables and modify various states, and it gets really, really complex. So why not just have one method that's named meaningfully, and it's got this visual state. So this is something I use a lot. Visual state is a word that describes how a certain element goes through its different visual states as something changes in the backhand. And the code obviously becomes much, much nicer like this. So good, simple code is good. But like I said, it's a huge topic, and I don't have time for all of that. I wish I did. Another thing that I specifically left out is this resized and paint method, which, as you can see, it has quite a few numbers in it. So this is quite common. This is actually quite contradictory because it's a very simple code. It's just setting the bounds of an element, putting it on the screen. And it is in fact simple code, but it's very, very wet, right? If someone wants to change this interface, it's gonna have to affect all those numbers in some way. And this is slightly better, right? We've extracted the width and the height and we've moved it into some private members, into some some variables there. But still, the x and y is still not that good. So you could continue down this way and have some like plus and minus there to shift the position based on the height and width. But then there's this margin. I don't know if it's obvious. So there's like 40. There's a slight 10 margin there. So it's just it's difficult to read. So over the past few years, I've come to realize that raw geometry and static layout is bad, because its inherent staticness is always a problem when you want to do modern GUIs. So there's better ways of doing this. I don't know how many people have seen this kind of layout code in Juice. Yeah. So this is definitely much better, right? At this point, this code is dry, right? There's no repetition. It's perfect code, right? It does everything it needs to do. It grabs this area, chops off, and if you haven't seen this, I would have a look at it first. But there's still a little problem with this kind of code. I'm going to quickly run this now. So it doesn't really resize well. I mean, you can write it in such a way that it does resize, but it's going to get complicated. And it has all these cases where, like, yeah, it tends to get into a very complicated kind of looking code. And it's not really dynamic in the sense that you can achieve. So maybe not very obvious, but maybe this will make more sense once I show an alternative. So yeah, I forgot to mention this paint method which this basically just draws two lines on the middle of the margin. You've probably seen it in the example. Just can show this again. So there's like two very fine lines in between there. So I want to suggest that if you want to do dynamic layout, you should use dynamic containers. There should be designated classes that deal with certain layouts. And there's a few languages out there that support this. So WPF has stack panels and grids and all different kind of tools for the right layout. But there's something out there which is better than everything I've seen, and it's called Flexbox. How many of you have used Flexbox? Yeah, quite a few. So again, it's a web standard really. It's CSS based, and it's come out recently. And I don't think it's actually supported on all platforms yet, even browsers. Just some of them support it. So it's very new stuff, and we're very lucky to have a C++ implementation in Juice. So if you haven't seen this, definitely check it out. Now, I'm afraid I wish I had time to do like a proper Flexbox tutorial, but it takes some time to actually get the hang of it. It's a very generic class, so it's difficult to get the right sense of it. So I'm just going to do a bit of a teaser here, I'm afraid. But this is the same layout code written in Flexbox. It's definitely more declarative. It's got some rules for justifying content, similar to how you justify words in a word processor. And what I've done here is I've removed that paint method, and I've made the separator an actual component. So then I can factor that in this resized call and in this Flexbox layout. So it's got two boxes. It's got one master box and one top box. The top box is essentially the sliders at the top. Let's close some of these. Yeah, you'll end up with quite a few of them open. Yeah, which one is this? So this is a Flexbox. Yeah, I decided to start making these sliders look a bit better in the meantime, and that's just me in middle. So sorry for these sliders that look terrible. But I think this is slightly better in terms of layout. So the space, the free space on the top row is distributed much better. So as I resize, it's always looking semi-decent. Now, I've removed some code from the previous, some hard-coded values, which some of them are still there. So the slider size is now 30, and I've removed that 90, which was the height. And I think if you're doing layout, it's better to have the parent set to the size and not have internal values hard-coded in your classes, because really that class should react to any external set sizes and whatever. And yeah, basically the less numbers, the better. Why did I just do that? So something to note here is if you're using Flexbox, it's actually fast to just create it on the stack there in the resize method, add your items to it, perform the layout, and then get rid of it. It's happening very quickly, and we've done some really complex layout in noise, and we've never seen it show up on the profiler. So that I would recommend just don't bother making private members for the Flexboxes and items if you're doing this. So I'm afraid I can't go into more detail into how this is done, but I wanted to point something out here that is, it's got these words here, vertical and horizontal. So this layout, despite the fact that it's dynamic, it's still kind of static in a way, because I'm always going to get this positioning, whatever I do. And at some point, as I resize, this is not a great use of space, because there's a lot of empty space in between those sliders at the top. So for something that's landscape-like, this doesn't look that great. So I want to show a slightly better example. This is still Flexbox. So it looks the same at this point. But then as soon as I reach a landscape, the three sliders switch orientation, and this one switches orientation. So this is interesting. This is not sure if all designers would really go for this kind of stuff, but this is just a proof of concept of what you can achieve. And you're probably thinking the code to do this is quite complex, and I'm not sure how many of you are thinking that this code will probably double in size just because I did that. And what actually happens, it's reduced in size. So one thing I've done is I've removed all of that vertical and horizontal notion. So I've got this slider item, which doesn't really know which direction it's being laid out. So it just has this basis, which is set to the slider size. So these are all Flexbox terms. But the main idea to keep in mind is there's no vertical and horizontal meaning here. And the only thing I've had to code is this little method, which checks if it's in portrait or landscape mode. And then the only thing it does, it just switches the flex direction. So the container now is not gonna flow from just row. Oh, sorry, just column. Is gonna switch to either column or row. And that's pretty much how you can achieve that kind of layout. So if you want to look more into Flexbox, I would say check this link out. It's the first one that comes up when you do a Google search anyway. So it's a good resource to learn, because it's got these embedded web views where you can try out stuff. And you know, it's on the web, so you know that is the correct implementation. Like, we've only added the Flexbox class recently in Juice, and we're seeing edge cases here and there. So sometimes while I was learning this, I was thinking, is this actually correct code, or is it just like a bug? So if you have those those questions, I would say just try it in the web. Right, so I wanted to get to the next thing. So this is some common code you've probably seen. Again, very difficult to find code that fits on the screen and is realistic in any way. But this is a very common class. So it's got some elements there. I've highlighted what is presentation related. So there's a color, there's sliders, there's a text button, there's some draw methods. But then there's also some callbacks here, which they're more like interaction logic. So is what happens when you press on a button. They're not necessarily graphics and layout. They have a slightly different meaning to them. And that's fine, but the only problem there is that what you usually do is you have some interaction and then you take an action and you change your state in some way. This could be a reference to an engine like an oscillator or some state. And again, this is simple because it's just a little class, but I'm sure you've seen things that become much larger and they tend to overcomplicate. And what happens is they complicate and everything gets mixed up with this layout code in paint methods. And you can be very organized and you can compartmentalize code, but people are, they're just going to write code and they're going to get running. And I think that is going to be a huge problem. If you keep writing code like this, it's going to be hard to have views that are simple. So I've kind of given myself away a bit there, but I've come to the conclusion that mixing layout and graphics with application logic is bad. It's possibly simpler in some cases that you should, if you have like a simple app, you probably don't need to start tinkering with this. But if you see your project growing a lot and you've got loads of screens, I think it's a good idea to step away from mixing layout and graphics. And this is not something that I've invented now. This has been researched and done for ages. So MVC is something that I've always been into, and that's essentially what this becomes. So I've got an oscillator view and I've got an oscillator controller. Everything that was to do with presentation is now in this oscillator view. Everything that has to do with interaction it's in this controller. It takes a reference to an engine and the oscillator view that it's controlling. So it can register to callbacks, and if you hide away all that nasty like plumbing, I think this is the best way to call it. This is a lot of plumbing you'll have to do, and plumbing is going to be ugly. So I want to encourage you to keep views clean and put plumbing in a place where you know it's for plumbing. And that will make your life easier when you're changing graphics. So as I said, oscillator, controller, and view. Now I've shown a very simple example there. So I think what really happens is when you start doing that, it's not as simple as that. This process of splitting a class into two takes you into other kind of problems. So I wanted to show a very quick example from the noise code base. Hopefully no one's going to sue me for this. And so this is a very common class in the noise code base. It's a track view. If you've played with the app, you might have seen it. Let's try to open it up. Here we go. So it's just the little track view with the clips and slots, and I can resize it. Now, there's something non-trivial about this. This is not a simple component that you can just create and set some variables on. This has got a list of clips inside. So if we look in here, we've got this owned array of slots, which themselves have clips. And if you saw there, then if you looked at this code, you see that I have some clips in there, and you might be wondering where did those come from. So in these kind of cases, what I tend to do is I tend to have a public constructor, which is the constructor that your application code will use. And then hidden, tucked away at the base of the class, I have this little macro. And this is switched on just when you're in the Projucer live build. Just quickly add some of them in the way you want. So that way, you still have these mocking. This is essentially mocking. And there's frameworks out there like Google's mocking that has some constructs to do this. But this is a very simple and raw example on how you can have mocks of objects without worrying about what it's connected to. So that example scales with lists and all kinds of things. But the idea is separating graphics and layout from app logic is good. Now, before, I didn't want to just leave it there because I think this is a very deep topic, and I've been dealing with MVC stuff for the past 3 years, and I think I only just got really the hang of it. Like it's just you have to do a few examples before you know exactly what should go where, and there are all these edge cases when they interact with each other. So it's not very straightforward when you have complex, big real-life projects. So there's a few rules that I keep in mind. So views should be dumb. They should be simple and dumb. They should be easy to even rewrite and throw away. And you should be able to do that with confidence without understanding what it's connected to, because that is what is complicated. So connecting it up, dealing with like app logic, that's the complicated stuff. Views is just pixels on the screens and layouts. It shouldn't be hard. So have that there, and then have controllers to deal with the interaction, so all the clicks and stuff that will interact to your model. And something really important to note there is the controller. If you look at the diagram in the left, the controller depends on the view, so the arrow represents depends on relationship. And the controller also depends on the model, which means the model is independent. I can compile that and put that anywhere I want. The view is also independent. I can run it in Projucer, I can do what I want to it, and then all the gubbins end up in the controller. And at least we all know where that is, and it's a bit simpler to work on important stuff when we have to. So this is a more real-life example of how this diagram scales. So you've got a user interface at the top. These are just 2 views, and then you've got a controller. Sometimes, I mean, this is something I tend to avoid. I tend to refer controllers to other controllers, but sometimes it's a good example. And then I tend to connect everything to state objects. So I don't like references to classes that do stuff. I just try to minimize the connection points to the very, very minimum. So it's only dealing with the parameter that is changing or whatever you're changing in the model of your class. And what's really nice about this is, I'm not sure I can really demonstrate this, but because all the views have no dependency, then what we can do is we can put them in a different translation unit. So when the Projucer runs, it doesn't even build any of that stuff at the bottom. It literally just builds the views. So in my list here, Projucer, and when I make a change, really only builds what's view related. And really, that wouldn't be possible if we had dependencies in our GUI. Or if it was possible, I'd be curious to hear how you would do that. So as I've said, there's some pros to views and controllers. It's good for making GUIs fast if you enforce this separation. It keeps the GUI loosely coupled. It's more maintainable, so that this is essentially the same thing. I'm kind of reiterating a bit. It's got a better dependency management, and it's actually, this is quite an interesting one. So once you've been doing this for a while, your team gets into this habit where they communicate using these terms, and it's so efficient because you know exactly all these arguments about, oh, what is this doing, why is this that, just disappear. Well, not all of them, but most of them disappear when you've got this effective, oh, I know this is view, I know this is controller. And even in source code, when you're browsing to stuff, when you see diffs and changes, you see if that's in the view, you know 1,000 problems that you don't need to worry about. So it's just a better separation, but obviously there are some cons. So there's a bit more boilerplate involved when you have these classes. So there's like, when you have just a simple editor, you subscribe to a listener, and then you don't really need to unsubscribe when that class is deleted, because that's the only one holding that reference. But in this case, when the controller is a different object, you always need to make sure your controller unregisters from listeners. And another downside of this is that it kind of encourages you to break apart everything, so you end up with loads of callbacks, and it could lead to event-driven programming hell, which is terrible. But I've got tips on how to avoid that. So this is it makes me sad that I probably won't have time to show you how you can avoid events and connecting sliders, but I can give you a hint. If you've got loads of sliders, for example, in Juice, you can use values. So you don't have to register every time to slider callbacks. You can just refer values to each other. So if you look at Juice value trees, that will help with that. There's another con here. You've got this extra lifetime to deal with. So when you just had one class, you can just create one class and then delete that, and you know that's done. When you've got a controller that refers to it, then you have to deal with the lifetime of that class as well. And this is something that we have built a framework for. Like a little construct that deals with this. We have like a little view controller pair in Noise that just deals with this binded lifetime. The most disappointing con is that everything that I've talked to you about is not really achievable if you have a very huge project. It's not something that you can just go home and do, right? Because we all know how difficult changing code is. But it is something that you can start doing more. So in your new classes, you can start building them in this fashion and then slowly migrate over. And then if you're so lucky to start a new project like we did, you can do it like this from scratch, and which is much, much easier. So I just wanted to do a quick recap. So coding for different form factors I think it's an increasing necessity nowadays. So we've got loads of mobile synths running out there, and maybe some of you are not, maybe you don't want to write mobile apps, but something that I found out recently is that AUV3, for example, will completely take ownership of the size of your plugin. So if you're using AUV3, you will get given a certain size. I'm not exactly sure on the details of this one, but Fabian can give you a few more. So we can prototype quickly if we follow a few good guidelines. Clean code is very important. So if there was one thing to take away from this is really all this magicry with view controllers and all of that. That really is not important if your code is not clean. It's only going to make it more complicated. So this is the first thing you need to get right, and then move on to other bits. Using declarative layout containers is better than setting positions in absolute coordinates. And separating views and controllers keeps views simple. This is not making a lot of sense, but here we are. So I think that's pretty much it.